Thanks for coming back. Today we're learning dynamics free body diagram.
Okay, so my name is Anastasia and I'll be teaching you dynamics of free body diagrams today. A free body diagram is used to show relative magnitude and direction of all forces acting upon an object. So we're going to start with an object that has a mass of m. You're so annoying!
Make sure you get that. No, you get that. It's part of the thing. Get it. Do not get me.
Okay, so anyway, before we're rudely interrupted, that mass is going to have what you call a force weight. Now, force weight is going to equal G in this particular situation. And G equals negative 9.8 meters per second. Squared. Sorry. Okay, so then you also have a force normal. Your force normal is going to be the absolute value of your force weight. Okay, so in this case, if you have a force weight that equals negative 9.8 meters per second squared, your Fn is going to equal positive 9.8. All right, so then you're going to have other forces. So it depends on which situation you're in. So like, let's say you're on an inclined plane, okay, and you have a mass.
You can't do that.
Okay.
Pause it. There's a way to pause.
So if you had this mass on an inclined plane, friction would be present at about this area.
Why?
Okay, friction is present because you have a mass that's rubbing against a surface that usually has a rough texture. Okay, so if the problem states that friction is negligible, then you can ignore friction, but I can guarantee you that if it's on an inclined plane, usually friction will be present. Okay, so once again, the friction is present at this very spot right here where the mass is touching the inclined plane. So, yes?
What does negligible mean?
Negligible means that you can ignore it. So if it says that friction is negligible, you don't have to worry about friction, which equals mu.
Thank you.
Okay, so back to the original problem. Here, you can have either a force applied or you can have a negative force. So your force applied could either be going this way, so Fa. A force applied going this way would push your object to the right, and then you can have a force applied going this way, which will push your object to the left. Now, if you have forces being applied in both directions, then your object isn't going to move. Okay? Now, it also has to do with the size of the arrows, if it's drawn to scale. Yes?
You also can have a force applied from an angle theta.
That's correct. Okay, so like I was saying, the size of the arrows also can matter if it's drawn to scale. So if you have an arrow over here that's applying a force to the right, and then you have a larger arrow over here that's applying a force to the left, your object is going to move to the left because you have a larger force on this side being applied. So, as my classmate Saran pointed out, yes, you can also have a force being applied at an angle theta. Now, this will usually be happening when you have an inclined plane, but we'll explain that in a more in-depth video later. So basically, you have different forces that can be applied, force going this way, force going this way. You know, it just all really depends on what your problem is saying. So, in summary, free body diagrams really just depict how your object is being acted upon by other forces that are around it.